Yes, I will. Let me get a presentation. Is it open? Perfect. Okay. Ooh, a bit loud. I'm Martin Levy, and unlike talking yesterday, today I will talk about IPv6. And I've actually it's got a mixture of stuff to talk about here. So, you know, we could, and I've said this before, we could spend hours talking about what is IPv6, and I'm not doing that. It doesn't need to happen at this point in time. But I am going to talk a little bit about, very little bit about our history on v6, which has been going on for quite some time. And I'm going to talk about this visualization of what's going on in v6. And the idea here is to provide something that, from a picture point of view, shows what's going on in the v6 world. And it gives a few pointers as to what other work needs to happen. And then finally, I'll talk a little bit about some of our tools, some of the work that we've done, and then I'll throw a few more things in just for fun and excitement. And I've got the mic, I've got the screen, so you get about 12, 13 seconds worth of Hurricane Electric story. But the bottom line is this. As a company that's been around a long time, we, many years ago, looked at v6 and said, we need to do that. And it wasn't commercially viable. And we put an awful lot of effort, and we got an awful lot of comments in the world about what we did and why we were doing this when it really wasn't ready for prime time. But I can tell you now that for the people, the networks that put that early effort in, some research networks, some commercial networks, it paid off. And it paid off because as much as you look at all the history of any company that stands up in front of an audience and gives a presentation, when you actually look at the timeline for v6, when you look at what's gone on in those last 11 years, it turns out the experience of doing v6 and having it out there in the real world has been the biggest win for us and the biggest win, I think, for customers and other players like developers out there. We started very early on, and then we realized we wanted to build something called Tunnel Broker. And Tunnel Broker enabled anyone, anywhere in the world that had an internet connection to bring up a v6 connection inside a tunnel, v6 with inside v4, and to start using v6. And there were people all around the world that took advantage of this because they couldn't get anything close to v6 inside their own location from their own ISP. Those tunnels still exist to this day. And in fact, there are nearly hundreds of thousands of them. But the reality is, as v6 is being deployed to more and more networks, those tunnels are slowly going away. And as much as we're known for these large number of tunnels, the reality is we would celebrate the day the last one is turned off, because it means that all the ISPs, yourselves, and other players around the world have been successful at deploying v6 to the end user. The reality is there's still a lot of traffic on those tunnels. There's a lot of tunnels to different places in the world. There are different types of tunnels. Some run BGP, some don't. A couple of things that happened, and I've got a few slides about this later, that are important that ISOC really promoted and got on the radar was World v6 Day about a year or so ago and World v6 Launch a few months ago, both in the middle of June, and both basically forcing content providers and connectivity providers to basically take a day, take a gun to their head and say, do v6 by that day. And it's funny, it worked. It worked really well. I've got some graphs, I'll share them in a minute. Okay, I've got as I said, I've got the mic, I've got the screens, I get to show you a network graph, a network diagram. The network goes from here, it goes to there, it goes over there. It's the usual thing. We don't need to have it in a marketing talk. But there's one important point. On our network, every single place on the network, every link is v6 enabled. And I make this point because we come across networks every now and again that are doing v6, oh, but they haven't actually enabled v6 on their internet peering port in a particular city. They haven't got to that yet. Well, get to it. Make v6 and v4 ubiquitous. Make them the same everywhere. If you're building a new connection to somewhere, enable v6 as well as v4. Because if you do that, you will make v6 easier and easier to use inside your network, and that will promote its use even further. Okay, like all good maps, it's out of date. So, go online, go see the latest one if you have an interest in it. All right, so let's talk about v6. Let's talk about what's going on. It's 2012. Bunch of numbers, then a bunch of graphs. So the first thing to do is to say, what has it been like over a long period? Let's look at, we're in a peering forum here. This is a graph that I've shown over time. It's grown and grown. So this is a graph that shows the number of ASNs. These are the building blocks of building networks that peer. The number of autonomous systems that are running v6. Now, plotted as a percentage is a little unfair, because one of those ASs may be a small university somewhere in the world. Another one of those ASs may be Google. And we pretty much know that that one AS for Google is going to generate a lot more v6 than that one small university. But the reality is that we just measure as ASs, and we don't differentiate. But the graph has been going up one sort of AS at a time, and if you look at this from basically about 4 or 5 years ago to now, you'll see that we're growing, but with a few interesting jumps. And those jumps really boil down to 3 events. First was IANA, the people that own the IP space over and above the RIRs. And when they ran out of v4 space, when they ran out of /8s to hand out to the RIRs, it was a big press event. And for that short period of time, because we have a very short attention span, the world talked about, we're running out of v4. What are we going to do? The internet's going to stop. Oh no, there's this thing called v6. So there's this great uptick. At the same time, ISOC announced World v6 Day, and we saw a mad rush to get ready for World v6 Day, and then a nice lull after that. Then we announced World v6 Launch, and we said, we're going to be ready and we're going to leave it on. And we took a bit of doing. It's always hard to have that second announcement. But again, we saw an uptick. And now we're sitting at about 14 and a bit %, which is great compared to 5 years ago, but still a long way to go. So what other graphs have we got? Visualizing v6 is easy. We can go out and look at every router. We can look at the number of routes that we see. And those routes are continuously increasing, which means that more players are going to their RIRs, they're getting v6 space, and they're enabling it on their network infrastructure. This is not a graph about traffic or usage. This is just, does somebody even know that they're meant to do something in the v6 space on a router somewhere in the internet? And the internet does boil down to that infrastructure that moves bits around and routers around the world. So 2 different graphs. The top graph is the number of network announcements, and we're sitting above 10,000. By the way, that's tiny compared to v4. 440,000 in v4 and growing. It is meant to be smaller, but at least the graph is going up and to the right. And here's the number of v6 announcements based on those ASNs. And again, we're seeing them go up. Notice there was that wonderful jump back in up to June 2011, World v6 Day, the amount of press associated. You can see people got their act together, and then the graph has slowed down a little bit. But it's still going up. It's still a lot of work. So that World v6 launch that happened a couple of months ago, let's see what I think about that, and and see if we can see some interesting data. Well, first off, let's look at a year before that. Let's see what happened. So we've got an interesting graph. This is the graph that we shipped out June of 2011. And it was literally of network traffic, V6 network traffic on our network. And look at what happened. World V6 Day was a 24-hour event that started at 0 UTC. The computer people are very much like that. They want to make sure everything's very accurate. And at 0 UTC, which was, by the way, 5 o'clock in the afternoon the day before in California, whoomph, upturned the V6 traffic. Now that was players like Google, Yahoo, Microsoft, Facebook, etc., enabling some of their sites for V6. And the mere fact that it went up instantaneously meant there was a pent-up demand. There were people out there enabled to use V6 as clients, as web browsers of some variety, whether mobile or on a desktop. And so the graph has got some interesting facts to it. First of all, the instantaneous jump of about 3x, 5x at the top here, but about 3x to 4x here. So the great thing about graphs are you go, that is a net effect, maybe pun intended. And then you see this sort of nice shape of going down and going back up again and going down over that 24-hour period to this point here. And that's indicative of time zones around the world and where the major players, where the major users of V6 were that we saw on our backbone. Now keep in mind, this is only our view on our backbone. There are many other views. Again, this graph is a little obfuscated like the ones yesterday. It has to be for certain reasons. But what happened at the end is really interesting. At the end, basically one particular player decided that they had no problems during World V6 Day. In fact, most people found they had no problems. And they said, let's leave some services on. So this is a major site that delivers video, and it's run by a large search engine, but I really can't tell you who that is. But the reality is that they left their video streaming on V6. They were that comfortable with that 24-hour test. A lot of other stuff got turned off. And you can tell that we still are higher than we were. So in that one day, we did a phenomenal test of V6. And what did people do the next day? Well, nothing. That's the point. In fact, actually, people didn't do anything for a long time. It took that decision to do World V6 Launch a year later to really get people interested. And World V6 Launch was a different type of event. It's an event where people said, be ready by this day, turn on V6, and leave it on. So let's look at the graph in a different format. Now we've got a graph that is 24 months long, and you can see World V6 Day here, nicely averaged out as graphs happen. And we can see that jump of before and after, and then we start seeing growth up until the beginning of World V6 Launch. Now, notice, I just want to go back 2 years. Notice here, this is nothing. Bits, tiny little bits, not very much. The reality is that V6, even over those last 2 years, has grown. This is various players bringing on traffic of some variety even prior to World V6 Launch. And by the way, this graph, just as a matter, we go back to the flow information I talked about yesterday. This is V6 web traffic. So the type of graph filter that goes on here is, show me all the traffic that's V6, but only TCP. Oh, and only TCP to port 80 or port 443. Nothing else. No DNS, no email, no BitTorrent, no Telnet, no nothing else, just plain and simple web traffic. And that's where this graph comes from. So actually you can pull out from terabits of data to this particular amount of data. And what's good is that you can tell that this graph was going up because people were getting ready for World V6 Launch. Why is World V6 Launch so important? Well, one of the things is that it takes away the statement, oh, I don't need to do anything on the access side, the eyeball side, because there's no content. Or the content people saying, well, because there's no one with V6 on the access side, we don't need to do content. This removes it. It takes one of the players and moves them forward, so there's no doubt that if you enable V6, there is a good return on that investment. You will get traffic. By the way, you won't get more traffic. It's a key point here. What you'll do is you'll get traffic that was flowing on V4, now coming on v6. Your overall traffic graph is going to stay the same. You may ask, well, why bother doing this? Well, the answer is not about doing it for today, but it's about doing it for the point in time when v4 run out and people don't have v4 and things can only live in the v6 world when that happens. And you may not even worry about that. You may say, hey, I've got plenty of v4 space. So this v6, Martin, you still have not convinced me. Okay, fine. I agree. You have plenty of v4 space. But what happens when the next Twitter comes along, the next Facebook, the next Google, the next something? Because it will. It always has. And it's sitting there in, whether it be Silicon Valley or somewhere else in the world, but it's sitting on a v6 only hosted service because it lives somewhere without v4 space. And now you can have all the v4 space you ever want, but if you haven't enabled v6, there's going to be things that you can't get to. Now, I don't know what that next thing is, because if I did, I wouldn't be here. I'd be, pitching it to a VC fund. But the reality is, there will be something. And collectively, we may not know what it is, but that's going to be one of the drivers for v6. Okay, so let's go back and talk about peering. I got a couple of graphs from that show what happened this year with peering. I picked DKIX here, and I picked AMSIX here, only because they actually publish their v6 independent graph. So because they publish it, it's easy to share. And actually, there's some interesting things going on here. First of all, yes, the traffic over the last year has been fairly consistent, and then it starts popping up, just like the previous graph I showed you. What was interesting is that there was this big spike that occurred, and this predominantly occurred because there are some players in Europe who have got very good v6 customer premise equipment deployment. They're actually moving a large amount of v6 traffic. And for a short period of time, that traffic ran over the public internet exchange before moving over to a private connection. And so we actually got an idea of what privately is running. And you'll notice that this has got a scale on it. So we're talking 10, 20, 30, 40 gigs of traffic here. So we're talking about a peak of maybe 15 to 20 gigs worth of v6 traffic that we got an insight in. AMSIX is a little bit more sedated, not because it has less traffic, but simply because it's just the way that all the internet peering operates inside Europe. Sometimes it'll be in one location, sometimes in another. But you definitely see a cause and effect there in the June timeline. By the way, the London Internet Exchange, the third largest exchange in Europe, actually isn't running any v6 flow stats at the moment, which is a bit bad timing, to be honest, but there's method to their madness. Okay, so let's get on to the visualization. Let's get on to the fun stuff. Let's go find out where the v6 stuff is in Africa, and let's go give you the tools to go find out more stuff and play for yourself. So Hurricane Electric, we built this tool. We built this tool and provided it to the public. The website is bgp.he.net. If you haven't come across it, write it down, put it in a browser, go play with it when you get home. Actually, very importantly, go play with it when you get home, because its goal is to give you an idea of where you are on the internet and how it interconnects to the rest of the world. You can look at anything from anywhere. We could sit here and look at what the internet looked like in Southeast Asia. We could sit here and look at what the internet looks like in South Africa. I chose the latter as it's probably more interesting. But it comes from public data. It does not come from the Hurricane Electric routing table. So it's as good as we can collect from all of the other collectors around the world. There's a University of Oregon does a project called Route Views. The RIP RIR in Europe runs the RIP RIS project. We're very grateful to both of those. And we take their data and try and put it in a more visual format. So what does it look like if you actually use it? If you just go to the website, it'll give you a very simple, you are here. This is your IP address. This is how it's announced, and where is it from. But it gives you a search bar. And the search bar is the thing that you want to type in and go look for fun stuff. The website, this is what a screen dump would look like right here inside the room today, and it shows that we're connected through CCOM, as we all know, because they sponsored the connectivity. But we can go and take the search bar and type IP addresses in, AS numbers, etc. there's a bunch of pages there that will give you statistics about what's going on the internet. Go have a look. I don't need to talk about them today. The fun part is how to visualize connectivity. So here's an example. This is what I'm going to show a few different ways. I'm going to show these a few different ways. So if you look at this graph, you're going to see one bubble connected to another bubble, connected to another bubble. And sometimes it'll get quite complicated. Those bubbles are your networks. Those bubbles are CCOM providing service to here, plus whatever upstream, whatever transit they've got. One player peering with another player. These bubbles are important. They are the fundamental building blocks of the internet. And in this case, I've got a very, very simple diagram, but what you can see here is that we've got one bubble connected to another bubble and then maybe to a third. The ones I'm going to show are much more complicated than that. The other thing we can do with this site is we can go take the RIR data and we can actually say, show me what's in a particular country. Well, again, I picked South Africa to display, but if you're playing online with me, and you can go pick any country you like. So here we see a list of network operators with their AS number, which becomes very important in this world, and we get to see them sorted by a different manner. Now, by default, we sort them by their adjacency count. An adjacency count is a very good measure of how well peered somebody is or how many BGP customers they've got. Again, different countries, different numbers, etc. The URLs are all there, and also you can go onto the site and see them. So let's look at what one of these graphs looks like. So I picked 3 providers in South Africa. I basically took the top list and looked at them, but I could look at anybody. So first off, and again, you actually can look at the AS number and work out who they are, but the point is I actually am not interested in talking about any one provider. I'm actually wanting more to talk about how you can interpret this data yourself, by yourself. So this is a provider who's got a pretty good V6 connectivity here and goes out through various other providers who then provide transit to the rest of the world. And this is sort of really not too messy. It's actually quite good. This is multi-homed, and we can see that there's plenty of connections here one way or another. Here's another provider, and you'll notice that it's a different diagram. But it's actually very sort of the similar mindset. And this is because when you live in the BGP and peering world and in the world of varying multiple transits, multi-home transits, you end up with slightly different connections. So again, we see 3 players providing the majority of service. By the way, thick lines means lots of routing. Thin lines means very little routing. And then most of the rest of the world here, and we've got a little straggler up here, which may or may not be an issue, but we'll leave that alone for the moment. And then finally, I picked a third one, actually much simpler. Much simpler. So this player simply looks like it's dual homed, but those 2 players both go back to the same individual player. And although it's a much simpler diagram, it's indicative if in this case I had looked at the V4 diagram of the beginnings of a V6 setup for that particular provider, but enough to get going. So again, your mileage may vary when you look at your own network, but this is just a set of tools. But this is not as interesting as what I want to show. This has been around on the website for a while. I want to show you some new stuff and some different stuff, because this is an African peering and interconnect forum, and it's for the whole of Africa. So what I did was I worked internally to build up a database that showed Africa in a different form. And what I did was I took every single country in Africa, and I took every AS number, every network I could find in that particular country, and I looked to see if they had any other connections to anywhere else in Africa. And what I was searching for was connectivity between one country and another country inside Africa to see if it existed. And I ended up with this diagram. And the first time I did this, I thought, no, that isn't right. And I'm going to show you a few more versions of this. But I went back and looked at the data a little bit manually, And it turns out that this pretty much, as far as we can tell, based upon the routes that are collected globally, looks like the way that V6 interconnects inside Africa. So we can tell that South Africa is a pretty major player here. They have a connection to Lesotho, Botswana, Zambia, Kenya, and of course we see a few other countries that have interconnects here. But you know, maybe we can say that there's no connection between South Africa and Uganda for V6. Remember, this is a V6 diagram. We'll talk about V4 in a moment. But this is a V6 talk, so I've got to talk about V6 first. And we looked at this data and said, well, wait a second. So let's assume this is right, that there's internet peering or even a transit connection between various countries. And in fact, there is. We sort of looked at, we built this table of how many peering sessions, V6 peering sessions we were seeing to the outside world. And we're still scratching our head about this. And then we said, wait a second. You know what's missing from this diagram is the rest of the world. Because the rest of the world really makes up where the V6 world is. And then we ended up with a completely different diagram. And now what we end up with, much harder to read, but I still think it's pretty readable. Up at the top in the square, we have the rest of the world, all consolidated into one place. And then we look at how many countries are running V6 and where they connect to. And what's the takeaway from this diagram? Well, the takeaway is, well, look, there's a big fat line to South Africa from the rest of the world. Yeah, there should be. I'll explain why in a moment. But what's interesting is that we see now all these other countries showing up, the ones we sort of expected to see, because they get their V6 from the rest of the world. They aren't connected internally inside the African continent. They're connected through their existing major transits back out to the rest of the world. This is sort of really interesting because this is a little sparse. Remember, this is not a cable map, the way we talked about in one of the previous sessions. This is not a network map. This is how BGP relationships show up and how routing would occur. So the good news is we see that there's V6 in Nigeria, Seychelles, Sudan, Senegal. We see it in Lesotho, but we still only see it through South Africa. Okay, that may be okay. We'll look at that in a moment. But we see all of these other countries here. Oh, by the way, we're still missing a pretty big list of countries. But we'll work on that in a moment. So this data, again, it exists inside the BGP routing tables, and the rest of the world is now considered just to be one entity. What happens if we now look at the rest of the world and we break it down by who's buying transit or doing peering with whom? So now we say, let's draw a box for every single country. Well, you can't read it. Can't even read it on the screen here. It's hard. There's an awful lot of connectivity. But I'm going to give you a clue. This here is South Africa, and it has an awful lot of connections to a lot of different countries. And what we're realizing is that all those countries there are the internet peering that some of the major players here in South Africa have got in places like London, Frankfurt, Amsterdam, etc. And there's a few other places, ISPs around the region that come into the rest of the world. ISPs out of Kenya, out of Egypt, etc., etc. But the reality is you've got to zoom in to see anything interesting. So I'm zoomed in. So this I find really interesting, and of course makes perfect sense. If I look at Angola, I see that its predominant connection to the rest of the world ends up going through Portugal. Makes sense, doesn't it, to a certain point? Good. Because if the BGP routing tables make sense, then I have faith in this. So V6 into Angola is coming out of Portugal. In Malawi and Sudan, we see a connection into Belgium. Maybe that's a satellite provider in Belgium. Maybe it's BICS. I'm not pulling the data apart to that level. And here in Cameroon, we see a connection to France. That makes perfect sense. That one absolutely makes perfect sense. So this diagram probably makes sense. It's complicated. It's meant to be complicated. In fact, actually, that's the key point that you get from this diagram, is that BGP and internet routing is complicated. But the cool part about this diagram is, look how many lines there are on there. And that shows that there's a fair amount of V6. It's just outside the region at the moment, as opposed to inside the region. Now, that's not all the countries that exist in Africa. I've left some countries out. If you don't see your country on those lists, that's because you're on this list. And this is the list of countries that have yet to do anything with V6 inside Africa. This is the list of countries that are managed by AFRINIC, or are part of the African continent. And of course, some of them are small, some of them are rather big. But at the moment, for example, if I pick the last player on this list, Zimbabwe, we aren't seeing any ISP there who's announcing V6 routes globally. So that is a classic problem. We got to fix that one. I don't know how. But so the answer is that for an ISP that's actually operating inside Zimbabwe, their RIR entries are actually coming out of the UK. And yes, I know that. But the reality is that from a programmatic point of view, we just can't work out how to handle that. If that's a special case, it could be fixed. But anyway, the point is, for a lot of the other ones, if you see your name on that list and you really aren't doing V6, go talk to somebody who can help you. AFRINIC have got a massive program to do V6 rollout in Africa, and they would be more than happy to help you. Now, remember I said this was all V6 related. So let's look at what V4 looks like, because it's very different. Here's the V4 diagram of just Africa. The good news is it's much thicker. It's got a lot more players in it. And what you see there is you see a lot more relationships exist. In fact, you get to see a lot of the relationships that we know exist within peering points inside Kenya and Tanzania and Uganda and Rwanda and the like. You see outside of South Africa, if this is readable, you see Zambia, Zimbabwe down here. You see connection to the Ivory Coast, and then various other connections that don't seem to have much to the rest of Africa, but now a lot thicker than you see for V6. And that makes sense, because we've always known that we've had V4 as a pretty solid delivery, and you've still got to convince people to do V6. But this is again, you see countries missing from this because they really don't have connectivity to the rest of Africa. I'm trying to think of an example off the top of my head. That would be, Morocco, for example, is not on here because Morocco predominantly connects out through Europe and doesn't connect to anywhere else in Africa at the moment. But if you try putting a map up of the whole of this, it gets to be really busy. This is sort of the whole of Africa with every country in the world that connects to it. And sure enough, you actually just about hit every country that has any form of internet. There may be a few islands that don't. But it's really too messy. If you zoom in, it's still hard to see. But here's South Africa. I can't even read the rest of this, to be honest. But the best thing to do is to look at this a little bit more online. But it does show that there's a very rich set of connections. The difference is, if I go back a page, that it compares to the connections inside the country, which could improve. Now, these graphs are not always 100% perfect. If a line exists, that's absolute. But occasionally there are missing lines. They're missing lines because it's hard to collect all the routing information that you need. So if you want to see more of this data, talk to your local internet service provider about doing route collection with either Oregon Route Views, which is now live in Johannesburg. I didn't know that until yesterday. But the cool part is that there are ways of getting more of this data. Okay, final point, simply, there's more data, go look at it. It's at bgp.he.net. Go spend some time, remember the URL, have fun. I'm running out of time, and I know I am very aware that I'm the last speaker of the day. So I'm going to jump through the last part of motivating people to do V6. And I'm going to simply ignore this slide, ignore this slide, ignore this slide, ignore this slide, except for I'm not going to ignore the next slide. We spent a lot of time over those years trying to convince people to do V6. We finally came across a way to do it, which worked. And the way we did it was about 2 or maybe 3 years ago now, is we basically offered people a T-shirt. Now, you can have... Okay, so some people are telling me their T-shirt hasn't arrived yet. Before we get to that point, Before you get to that point, government programs to promote V6, RIR programs to promote, these are all good things. I'm not saying they're bad, but I'll swear blind, T-shirts. Just go for the T-shirts. We did this T-shirt. It's actually, like the T-shirt I'm wearing here with lots of geeky stuff on the back of it. But the day we announced it, I just want to show you this. The day we announced it, we had this massive jump in the number of people that came to our testing site. By the way, to get the T-shirt, it's very simple. To get the T-shirt, you just have to go through a set of online question and answers and tests. And if you run any network, in theory, this should be easy to answer. In theory. But the test turns out to be a little bit more complicated than that. So the test turns out to say, well, the easy thing is a set of questions. How many bits in an IPv6 address? Well, that's easy. But then it says, have a look at this website and tell us what it says. Oh, by the way, the website's only available on v6. Now, all of a sudden, to pass that test, you've got to get your browser to work on v6. Okay, not a problem. And then we say, send us an email. Oh, send us an email via v6. Receive an email via v6. Edit your DNS so that your DNS is actually v6 enabled. And we go through these steps. There's about 10 or 11 of these steps. And each time what we're doing is we're making people do more and more of their infrastructure to be v6. Now, it could be their home computer or their home server, or it could be a massive corporation. We've managed to get people from all, from all parts of that spectrum. But the bottom line is we get to do it. Of course, the hardest part for us has been shipping the T-shirt. The number of returns we get for random addresses around the world are pretty high. But if you come see me and we can deal with this. Oh, by the way, if you ask me for a free T-shirt, the simple response is go take the test. It's a fundamental requirement. Okay, this is the final slide. You got to have an IPv6 mindset. You've got to look at all my graphs. They all go up to the right. This is sort of the mindset you've got to have. You've got to have a positive v6 mindset. It's up and to the right all the time. And really that's the end of the message that I have. Now, do I actually have any time whatsoever left? We'll take a few questions, but can I take 3 minutes on a different subject? Because the cool part is that I want to go ask one particular person in the audience about their v6 experience, because it's great numbers, but I need a microphone. Can I get a mic down here? And they're not staged questions, I just know what they're going to be. All right, this is Louis. Introduce yourself.
I'm Louis Marie from University of the Free State.
So the university is here in South Africa?
That's correct, yes.
Okay. So you ran a network that was only v4, and you decided that you needed to implement v6.
Yes, that's correct.
How long ago was that?
Well, we started about 2 years ago just implementing IPv6 DNS, but unfortunately the way that our network was designed would make it really difficult to implement IPv6 properly.
So you made a change to your network? And
yeah, we made a change to the network. I actually consulted with Andrew Austin, who is the ex-CTO of Tenet. So we took up a project to redesign the entire network. And as part of that project, we decided that we need to implement, we properly need to implement IPv6 and multicast in the network as well.
Okay. So from the point you actually started the migration to the point that you actually had working a network with v6, how long was that?
Well, we basically completed that entire project. That's now for 19,500 wired ports as well as the wireless. We did that in 4 weeks. Basically, I mean, we were working in the evenings. And the great thing about it, had zero impact on the end users. We basically rolled out a dual stack IPv4, IPv6 network. And we enabled all of our proxy servers and some of the other services such as mirror services as well.
How many users on your network?
It's 37,000.
37,000?
Yes.
Okay. How much bandwidth do you think you now have that operates through v6 versus v4?
Well, I mean, out of our total, which is about 200 megabits per second for the university, we're currently doing about 120 megabits via IPv6.
So greater than 50%? It's
greater than 50%. Obviously, some of the majority content distribution networks such as Akamai and Google and Facebook content delivery network. But I mean, it's still a massive amount of IPv6 traffic. I mean, we never even thought it would so fast go up to that type of number.
Okay. And implemented on brand new equipment, legacy equipment, a mixture of the two?
No, we actually implemented it on the existing equipment. I mean, it's obviously not state of the art. We're actually using Hewlett-Packard ProCurve equipment. So it was a bit of a tricky implementation, but I mean, we managed it. We implemented IPv6 via AfPIF3. Unfortunately, we were not able to do that via ISIs. It was unsupported by the equipment.
So, so additional CapEx cost, very minimal?
It was nothing. We basically just re-rolled out basically the entire network on existing equipment. The firewalls and everything we had was already IPv6 enabled.
Okay, cool. Thank you very much.
Thanks.
It can be done. All right, I'm done. I've got time for questions, I presume? Thank you. Yeah, I'll stand.
All right. Thank you very much. I think we should give an applause to UFS for that effort.
Yes. Don't mind.
Okay, so I'll use this. Okay, let's take questions for Martin Levy, I think. Okay, go ahead.
Just a comment, really. Matthew Chigwende, Liquid Telecom. We use your tools. I find it very, very useful. It's quite impressive, I must say. I just wonder, you know, I know people on BGP, you collect your tools mostly from BGP tools, isn't it? But I just wonder whether it's affected by people putting filters or anything on their routers, and what would you advise, like, transit providers, what they should or should not do on their network, so that the presentation here is a correct reflection of what's actually happening?
Right. So this is a great question. The tools, I mean, we're not the only people that use this data. It's used by many. There's the reason why it's collected, is to be used by many different people. The more data, the better. So if you're running a transit network, and more importantly, if you're even at an exchange with a collector of some variety, like the Oregon Route View collector that exists in Johannesburg, then feed the collector specifically and try and feed it a full routing table versus just a customer routing table, which some people do. This gives the collector yet one more view on what the rest of the world looks like. At the moment, we are dependent, everybody in this, whether they be researchers or whether they be network operators, are dependent on route collectors being fed nearly voluntarily. But to be honest, hundreds and hundreds of networks deliver their connections. But if we're sitting here with inside Africa, we would turn around and say, no, there needs to be more points to be collected, whether it be from major providers in countries like South Africa or other countries. It does make a difference. It gives you a different view than a view that you see from Europe or the United States or anywhere else in the world. The question is, are the collectors filtered? Well, the great thing about the global internet is, in order to use it and you announce a route, you need that route to propagate everywhere on the global internet. If it doesn't propagate, you won't get connectivity. So routes, if they're not fed locally to one, like by an ISP to the route collector, will show up somewhere else, because those routes have to be seen globally in order to be useful. So the route will always show up somewhere. Within the hundreds and hundreds of ISPs feeding the collectors, it'll show up somewhere. We have to do a very large amount of filtering to reduce the data down to a logical set, as opposed to a massive amount of redundancy. But by feeding feeding more data here with inside Africa, all of those graphs, all of those tools will improve. For instance, RIP RIS has a phenomenal set of tools on its website, very different than ours, a totally different view, a totally different methodology. They can do a lot of time-related playback, which if you're a network engineer is very valuable. But again, they need the data, and so there's a requirement to throw extra data into the collectors. So, yeah, good question.
Any other questions?
It's the end of the day.
Okay, good. So thank you very much, Martin.
Thank you.
A round of applause for Martin. So we've come to the end of today, and next thing, no social. Oh. Anyways, so we have a social event lined up. The gala dinner is going to be today, and I think for that I'd like to invite Howie to come and give us the details as to what will happen, how we get to the social. Howie.
Absolutely. Oh, cheers. One mobile mic. Okay, so after those fantastic presentations, we're now going to be meeting at 6:30 in the lobby of the hotel. The buses that are going to be taking us to the venue tonight for the dinner will be parked outside, but there's going to be lots of staff from the hotel to guide you onto the buses. So the dress code for tonight is, well, what is the dress code at an AfPIF event? I think it's business casual, smart casual. So, and that's the detail. So we look forward to seeing you all downstairs at 6:30, and the buses will be coming back around 10:30. Any questions? Oh, that was going to be a surprise. Okay, it's going to be Chief Boma's at the Indaba Hotel.